Hello everyone, you're welcome to today's class. So we're going to continue from where we stopped in the last class in differentiation. Today I'm going to be considering a topic titled chain rule under differentiation. So when we talk about chain rule, here we have chain rule. So the formula for chain rule is given as dy over dx is equals to dy over du times du over dx. So I'm going to show you how this formula is applied in solving examples. So when I'm solving this example, you see the application of this formula, where the formula comes in. Now, I have this question on the board. It says I should find the derivative of the following, which is a, y is equal to 3x squared minus 2, all in bracket, raised to power 3. Then b, I have y is equal to square root of 1 minus 2x raised to power 3. Now, it says I should solve this now. Now, this kind of question, differentiation that comes like this, I will only solve them using chain rule. That's the best method to solve this kind of question. So, solution. So, I'll come here and say, that's A. I have my y is equals to 3x squared minus 2, all raised to power 3. So, now I'll say, what is inside this bracket? I'm going to say, let it be equals to u. So, let u be equal to 3x squared minus 2. So let u be equal to 3x squared minus u. So since u is equal to 3x squared minus 2, then what is my y? My y is equal to now you see, instead of 3x squared minus 2, I have u. I'm putting it in place of u. So I'm going to have my y will be equal to u raised to power of 3. Because here I have this 3x squared minus u, which I'm putting u, 3x squared minus 2, which I'm putting u in place of, is raised to power of 3. So I'm going to have u raised to power of 3. So I'm going to differentiate this u to respect to dx, while I will differentiate y to respect to du. So I'll have du over dx is equal to differential of 2, which is constant, is 0, while differential of 3x squared is 6x. So now I'll come here, differential of this, dy over dx, or over du. I'm differentiating my y to respect to du. So differential of my y to respect to du, I'm going to have differential of this, I'll have it as 3u squared. That's my differential. Differential of u raised to power 3 is to respect to du is 3u squared. So I'll come to my formula. My formula, using the formula, dy over dx is equal to dy over du multiplied by du over dx. So now my dy over dx is equals to, now my dy over du is given as 3u squared. So multiplied by my du over dx is given as 6x. So I'm going to have my dy over dx is equal to 6 times 3 is going to give me 18. So I'll have 18x u squared. So remember I said let my u be equal to 3x squared minus 2. So I'm going to substitute it back here. So substituting my u, which is 3x squared minus 2, I'm going to have my dy over dx is equals to 18x bracket 3x squared minus 2 then all squared. So this is my final answer. So with this, I'm done with the first example. So that's my final answer. So I'll move to the second example, example 2, which is my b. So my b, I have y to be equal to square root of 1 minus 2x raised to power of 3. So that's my b. So this is the same thing as me having my y to be equal to 1 minus 2x raised to power 3, then all raised to power of 1 over 2. So from here now, I'll say let my u be equal to what is inside the bracket. So let u be equal to 1 minus 2x raised to power of 3. That's my u. So if my u is equal to 1 minus 2x raised to power 3, then my y becomes u raised to power of 1 over 2. So I'm going to differentiate this with respect to dx. So differentiating here, I'll have du over dx is equals to differential of 1 is 0, y differential of minus 2x raised to the power 3, I'm going to have minus 6x squared. So here I'll have dy over dx is equals to differential of u raised to the power 1 over 2. I'm going to have it as 1 over 2 u raised to the power of 1 over 2 minus 1, which is equals to 1 over 2 u raised to the power of minus 1 over 2. So that's what I have. So I can come here and say my dy over dx is equal to, this is the same thing as me having 1 over 2 square root of u. It's the same thing because 1 over 2 u raised to the power of minus 1 over 2 is the same thing as me having 1 over 2 square root of u. So all I just need to do is just to multiply all I need to do is just to say, using the formula, so using the formula, my dy over dx is equals to dy over du times du over dx. So my dy over dx is equal to, my dy over du, I have it as, here is du. I'm differentiating to respect to du, not dx. I'm differentiating to respect to du, not dx. So my dy over du is 1 over 2 square root of u, then multiplied by my du over dx is what I have as minus 6x squared. That's my du over dx. So now my dy over dx is equals to, so if I multiply, I'll have minus 6x squared divided by 2 square root of u. So if I substitute my u, this 2 here will go 1, 2 here will go 3. So I'll have it as minus 3x squared divided by square root of u. So I'll have it as minus 3x squared divided by, remember I say let my u be equal to 1 minus 2x raised to the power 3. So I'll have it as minus 3x squared divided by square root of 1 minus 2x raised to the power of 3. So this is my final answer. So with this, I'm done with this very example and this very topic, differentiation using chain rule. So hope is all cleared and we all understand. So thank you very much for following us through today's class, and hope to see you in our next class where we'll be treating differentiation of exponential functions. Thank you.